Hello, today we're starting Unit I, and this is the first section. We are doing 12.1. I split 12 up into two different sections. Today we're going to focus on what's called sequences. A sequence is a function whose domain is a set of consecutive integers. If a domain is not specified, it is understood that the domain starts with 1. The values in the range are called the terms of the sequence. So I'm going to talk a little bit more about this when we go ahead and look at an example down below. A finite sequence has a limited number of terms, and an infinite sequence continues without stopping. So if I take a look at this, this would be considered the terms of my sequence, 2, 4, 6, 8. There's no dot, 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 so our sequence stops at 8. This is an infinite sequence, and it goes 2, 4, 6, 8, and continues on forever. So 10, 12, 14, 16, keeps on going. Like I said, both of these are the terms, and that would be considered the range. The domain is saying this is our first term, this is our second term, our third term, our fourth term. So a sequence can be specified by an equation or rule. For example, the sequences above are described as 2n. That means I take my first term and I multiply it by 2, so 2 times 1. That's where I get 2 from. This is my second term, so I take 2 times 2. That's where I get 4 from. I'm going to talk a little bit more about this when we go and do the second set of examples. First set's pretty easy. It says write the first 6 terms of the function. So if this is my rule, I'm going to plug 1, 2, 3, 4, 5, 6. So 1 plus 4 is 5. 2 plus 4 is 6, 3 plus 4 is 7, 4 plus 4, 8, pretty easy, right? 5 plus 4 is 9, and 6 plus 4 is 10. So the first 6 terms would be these 3 and these 3. And if you want to relist them, you can go ahead and write 5, 6, 7, 8, 9, 10. Okay, this one gets a little trickier, so you definitely might want to write this one out. So I plug in my first term. I have -3. N becomes 1. So 1 minus 1 is 0. So anything to the 0 power is 1. Now we're going to do -3, and we're going to plug in 2. So 2 minus 1 is 1. So -3 to the first is -3. And then we're just going to keep on going. So -3, you plug in 1, 2, 3. 3 minus 1 is 2, so -3 squared is 9. So look what's happening. We went from a positive to a negative to a positive. This is going to become important later on when we write our own rules for functions. So this is going to be plugging in 4. 4 minus 1 is 3, so -3 cubed is -27. And we're going to keep on going here. This becomes positive 81, and this becomes -243. So these are the 6 terms of my sequence. Go ahead and try the next example. So everywhere I see an n, I'm going to plug in a 1. So I'm going to have 1 over 1 plus 1. That's going to give me 1/2. 2 over 2 plus 1 is going to give me 2/3. And you'll be able to recognize a pattern too. So this is going to be 3/4. So what do you think the next one's going to be? 4/5, 5/6, and 6/7. So again, there's our first 6 terms. So I want you to go ahead, take a minute to pause the video, plug in 1 through 6 into this rule, and go ahead and just write your 6 terms out. Okay, now this is the tricky part for students, and practice is going to make perfect. We are going to write our own rule. So this time you're going to be given the sequence. It says if the terms of a sequence have a recognizable pattern, then you may be able to write a rule for the nth term of the sequence. So we're going to write a rule where I plug in any number, it's going to work. If you are only given the first several terms of a sequence, there is no single rule for the nth term. So what this is saying is, me and you may have different rules, but they still may be correct. And you can figure it out by testing however many terms they give you. So for example, this one has 4 terms. Now here's the most difficult thing students have with this. When you're in grade school, you're used to saying, how am I going from -1 to -8, -8 to -27? I don't want you looking at it like that. I want you saying, this is my first term. What do I do to the number 1 to get -1? This is my second term. What do I do to the number 2 to get -8? This is my third term. What am I doing to 3 to get negative 27? And this is my fourth term. Same thing. So we're saying, what do I do to all 4 of these numbers to get the sequence above? This one's a little bit tricky because I can see that it's odd. So here are the things that I like to try. I like to say, do we multiply all these by something? Do we divide all these by something? Add, subtract. If none of that works, sometimes I'll try simple combinations. I'll say, what if I multiply this by 2? And then if I multiply 1 by 2, I get 2. How can I get negative 1? Oh, subtract 3. So would 2 times my term minus 3, will that work? Well, let's try it. 2 times 2 is 4. 4 minus 1 is positive 1. No, definitely doesn't work. So then I start thinking of powers. If I take 1 to the certain power, will that work? 2 to the certain power? Well, I know 2 to the third gives me 8. I know 3 to the third gives me 27. I know 4 to the third gives me 64. So something is happening. It must be something to the third power. But how come these are all negative? So what I would do is do negative. So if I plug in 1, that becomes negative 1. Negative 1 cubed is negative 1. I plug in 2. That becomes negative 2. Negative 2 cubed is negative 8. This is my rule. So we write it like this. And that one is a tricky one. I started off with a pretty tricky one. Okay, now this one, I can see that there's fractions. So now you want to look at it separately. I want to look at, what do I do to 1 over 1? What do I do to 2 over 2? How about 3 over 3? How about 4 over 4? So what's happening? Let's look at the top. Now this one is written as 1. So how can I replace 1 with 3/3? I can replace 3 with 3 over 1. So what's happening in the numerator? 3. Nothing's happening. It's just 3. What's happening in the denominator? It looks like it's 1, 2, 3, 4, 5, 6. 3 6 is the same as 1/2. So you're doing nothing to it. You're just replacing it with the first term, the second term, the third term, the fourth term. This is my rule. Now, I just realized I didn't finish reading the directions. It says find the next term, then write the rule for the nth term. So I have to finish filling in. This is 1, 2, 3, 4. This is the fourth term, so I need to write what the fifth term is. The fifth term would be negative 5 cubed. That would be negative 125. Okay, this one is 1, 2, 3, 4, 5, 6. I need to write the seventh term. So my seventh term would be 3 over 7. Okay? All right, let's go ahead and do the next problem. Okay, again, this is my first term, second term, third term, fourth term. What am I doing? And the more you practice this, the better you get at it, okay? So I look at it and I say, okay, what if I multiply by 2? Nope, that won't work. What if I multiply by 2 and add 1? Let's see. Multiply by 2 and add 1. 2 times 2 times 1 is 2 plus 1, 3. No, that didn't work. Okay, let's think about it again. What if I square something? What if I square each of these? If I square each of these, how many am I off by? I get 1, that's a 2. I get 4, that's a 5. I get 9, that's a 10. I get 16, that's a 17. So actually, if I square it and add 1, that becomes my rule. What's the next term in the sequence? I need the fifth term. So plug in 5. 5 squared is 25. 25 plus 1 is 26. Okay, so that's probably the trickiest part, like I said again. So you're going to take the number 1, the number 2, the number 3, the number 4, the number 5, and you're going to say, what am I doing to each of those numbers to get the sequence above? Go ahead, pause the video, give it a try. Any questions, comments, or concerns right at the bottom of the paper, and I'll see you tomorrow in class.